part two, and I'll hope to get to how I would explain the phenomenon of it is diffraction, refraction, let's say, in the two-slit experiment, but more importantly in the single-slit experiment, in the surface phenomenon. And I've pointed this out before. This is just about surfaces and what happens when photons interact with material surfaces. Yeah. Obviously, when you have the surfaces really close together, the odds of the photon going really close to the surface gets higher. Yeah. Anyway, so I'm going to read some comments, and I'll play Professor Lewin, and then I'll hopefully have time to give you the diagram of the way the game is really played. Alright, so Alpha Day. This is on Piro's video. You're always going to struggle explaining science to each other without drawings and equations. Okay, now drawings I think are really important, but equations I don't think are terribly important, frankly. Good if you have one, especially the simple ones. E equals mc squared. Yeah, okay, that's, why not? The inverse square rule. But see, I could say inverse square rule and it's understood that this 4 times half the difference, 4 times the effect. I think that's a simple way of saying it. I don't think that's really an equation per se. This visualization, I think, says more. I move half the distance, my hand gets 4 times bigger. I think that says more than an equation. Equations are just descriptions of reality, descriptions of relationships that we are claiming exist. Proportional relationships. That's why they're in the form of fractions. And that's it. There's nothing special about equations. They aren't the reality. They're a description of the reality. And there's lots of ways to describe reality. I give you equations showing why a solar panel on a roof is not as efficient as a solar panel actually facing the right direction and that can move with the sun, can at least tilt with the sun. Now I can give you equations demonstrating why, okay, there's a relationship between the efficiency of the solar panel and that circumstance. I can give you equations, but you don't need equations. I can just point out quite obviously, look, more photons hit it. Right? Photons equal energy. Yeah. You don't need an equation. Anyway, you know you have a whiteboard R2, Gary? Question mark. I know you have a whiteboard R2, Gary? Question mark. I don't have a whiteboard R2. And even if I did, I have a white piece of paper, which is okay with me. Look, Piro already did some drawings, and they were absolutely horrid. You didn't even come close to accurately drawing the two-slit experiment, so there's no point. Giving an imbecile, I mean an asshole, I mean a retard, I mean a fucktard, I mean a fucking troll, I mean a jackass who can't listen to anything, who has to drink through every conversation, giving him a whiteboard is just pointless. Because he doesn't take this subject seriously. He's just going to keep spouting what God told me. My mommy said. Feynman said. He's not going to have he's not going to rationally deal with this subject. He won't answer the explicit question. He just keeps saying, tunneling microscope, tunneling microscope, tunneling microscope. That's not an answer to the question. It's bullshit. So anyway, that's a good point. No, it isn't a good point. A good point is that you got to quit drinking, especially in physics conversations. And there's really, maybe it's like I said, maybe it's fun for other people, but frankly, I try to have serious conversations, and you can't do that with a drunk. Anyway, God. So this is the troll, Makul CS, Malul CS. Obviously, he has an icon of fantasy physics. It's not reality. It's a distortion of reality to please your sensibilities. to give you what you want emotionally rather than factually. God, listen to when men talk about physics is fucking infuriating. Yes, listening to you talk about anything is infuriating, irritating, obnoxious, worthy of vomit. You're just a lying, scuzzy troll who never argues the argument. You just keep arguing the arguer because you suck, because you're a piece of shit. You're just a character assassin. And character assassins are, generally speaking, people with no character because they have nothing to lose, right? They don't mind assassinating people's characters because they have no character to shoot. You piece of scum. I mean, there's videos disproving what he's saying about water and single slit diffraction. No, there aren't. You can only... Look, Professor Lewin drew the picture. This is what happens if you put straight, linear waves, not overmodulated waves, right? Not waves created by three sources. That's the video, the image Piro showed in the thing. If you read about how that image was created, there's three sources on this on the other side of the single slit. There's three sources creating the wavefront that creates that image. It's not a natural consistent wavelength source. If you take a consistent wavelength source that's not overmodulated, meaning you don't punch the water faster than the water can rebound. You do understand a sine wave is a rebound wave. You can't create the rebound if you don't give the water time to rebound, right? So if you poke the surface so fast, the water can't rebound, you'll have an overmodulated wave, which means you'll have waves on top of waves. That's not this. That's not what light is. Light is an overmodulated retard. Especially monochromatic light, retard. And this is what you get. Now, Professor Lewin didn't draw that because he's stupid. Okay, he draws some other things because he's stupid, but he didn't draw that because he's stupid, because he doesn't understand that single slit water waves have automatically interference patterns in them. They're automatically in there. No, he didn't draw them because there is no interference with a single slit and a undermodulated wave. Fact. 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 Liar, 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 liar. So, I mean, there's videos disproving what he's saying about water and single slit diffraction. No, there isn't. There's mountains of evidence for these things. No, there isn't. There's no evidence for those things that isn't manufactured evidence. Many of the images of gravitational lensing are manufactured images in the sense that they're images of stuff, but there's no way Einstein would say, yes, that's gravitational lensing. Because there's no gravity where the lensing is taking place, and you can't do that in physics. But you don't know anything about physics. Coming up with bullshit excuses after bullshit after excuses. No, I think Piro's the one coming up with excuses and evasions. Tunneling microscope, tunneling microscope. No, that's not the subject, retard. The subject is single slit interference patterns. Okay, and why they don't exist in water. Yes. Why a piece of... Okay. Coming up with bullshit excuse after bullshit excuse about why a piece of blatant evidence isn't valid. So what is the blatant evidence? He's saying there's blatant evidence that when I take linear water waves and put them through a slit, they interfere with themselves, a single slit. There is no blatant evidence. You're just wrong. Your reasoning is crap. You're obnoxiously arrogant and to be profoundly ignorant and obnoxiously arrogant should be a crime that has you run over by a steamroller. When the only real reason is because it doesn't align with his bullshit theory. No, it doesn't align with rational, common reasoning, logic. The idea of a photon going through two slits is illogical. The idea that a photon goes through a single slit and interferes with itself is illogical. That's why I'm saying there has to be a better explanation, retard. Because that's a silly explanation. It's fucking sillier than the Flintstones monkey camera. I mean, theoretically, yes, you could teach a monkey how to chisel images, but realistically, come on. Where's the monkey's bathroom? I mean, what are you feeding the monkey? How expensive is this camera if you have to feed it every day? Does the monkey get any free time? It just doesn't make any sense. Again, he just twists things so... No, I think you're twisty, buddy. Yeah, just twist things so they fit with his theory. It's complete nonsense. So again, I'm saying that what's complete nonsense is to say there's single slit wave interference. There isn't in any other substance on Earth that isn't overmodulated. You will not have an interference pattern, except with photons and electrons. And again, the explanation for electrons is different than photons because they're different things. But you know, that requires you to suspend your narrow, tiny brain and expand it a little and recognize that this pattern we're talking about is the simplest one in the universe of patterns. So yes, things will do this for different reasons because it's a simple pattern. Really, why bother talking to someone who dismisses real-world evidence so freely? So again, what real-world evidence did I dismiss? That what? Single slits, water waves makes interference patterns. No, it doesn't. It's like talking to a religious... No, you're a religious person, clearly. An obnoxious, bigoted, myopic, close-minded... nasty person. You're a nasty person. It's like the religious fucks against abortion because they don't want people having sex, not because they give a shit about fetuses. You're a dishonest, disingenuous, small penis, petty fucking creep. And the only reason why you're making these posts is because you've lost an argument and you're a petty weasel. And why give him an inch when he comes when it comes to this stuff? Well, they have to give me the inch because frankly, they don't have a rational counter-argument, as Pirro has demonstrated. He doesn't deserve it. He's a dick. Well, you're a skanky, diseased cunt. But yeah, this shit is unwatchable. Can't do it anymore. Well, I would be grateful if you don't do it anymore. I'd be grateful if you just fucking die because you're a piece of shit. You're a liar and a piece of scum. Yeah, and the sooner you're dead, the happier I'll be. Because you're worst... From my perspective, you might as well be an AIDS virus or herpes or some other pieces of diseased crap. You're a piece of shit. You have nothing to do with the truth, honesty, integrity, or character. You put up nothing. You're just a lousy, cheap character assassin. You haven't made one fucking salient argument. You post links to crap. Okay, the last link he posted me to was some bullshit experiment where the results didn't escape the margin of error. Now you do understand what that means, is right? They came up with a positive result, but the positive result didn't escape the margin of error. I mean, is that demonstration of something? When an experiment doesn't escape the margin of error, you know it's an experiment that has no value. We do know that, don't we? Fuck. Alright, anyway. Pirro says, I'm not going to read this one. Blah, blah, blah. It's kind of hard to say whose side he's on anyway. He says, level of magic and Gary knowledge of the issues. I don't, you got to catch up to that. Well, I don't know what magic has to do with any of this, so fuck that. And then Pirro says, he was kicked. Question mark. Yeah, funny. Fuck you. Again, you're going to have to make some kind of apology or send some sign of cash, but either way, that's it. I'm not putting up with it no more, buddy. You've done this 4 times now or whatever it is, last year or whatever, or 2 years. Well, it doesn't matter. It's enough times for me to say fuck you. You have these insipid, lousy, creepy, scummy people in your room that just waste time with their crap. Well, they argue the same way you do. They just keep changing the subject. So, yeah, that's why you like them, I guess, because they just keep changing the subject. So, anyway, moving on. So, let's do the Professor Lewin two-slitty thing where I left off here. I just want to get to some of the language he uses and just point out how this is what's kind of wrong. Is that, lots of conclusion drawing, not evidence for conclusions.
This is where it is. You're going to see it there, and in order for you to see it, I have to make it completely dark.
Yes, we already did this part, but we'll do it again. No point in, fiddling for a few moments. I'll probably need them later, but yeah, I got time.
When you look here on the screen, you will see areas which are distinctly dark, and you see areas whereby you see the light. In other words...
Okay, so let's just be clear. He just did the mathematics that basically did this, that said all of these lights are exactly the same intensity. He called it an intensity diagram. He drew it, all the same height. He called them, what form of, kilowatts. He used kilowatts as the product of his equation would be in kilowatts. So we would know how many kilowatts all these were, and they were all the same number of kilowatts. Now, quite obviously, this is not the same kilowatts as this. Obviously, this over here has nothing, not even close to the same kilowatts, and, the little dims here. So obviously none of this shape is anywhere in his mathematics. Anywhere in it. Nowhere. Just completely ignored. So here's the result of the experiment. And obviously the equations, as Hothloday would say, these precious equations, really don't have a hell of a lot to do with this. And what we also see, if you'll notice, it depends on how well polarized this light is, and how precise the wavelength is, right? When they say, oh, the light is red light, well, that could mean you could have photons in the light that are at a wavelength of, say, 600 nanometers, and another one's, 582, and another one's 607. That variation is what creates a lot of slop, bleed over. So, I mean, the darks aren't exactly as big as they should be, technically. Alright, but anyway, that's another side issue.
You see the pattern that we just calculated. You see construct...
Well, like I said, we don't see that pattern. The pattern you just calculated would have just a bunch of straight bars all the way to the end, and they would just diminish based on the light. Yeah, I don't know. They've diminished because the slit wouldn't be wide enough to create anymore.
Interference, and you see
no more ends. You'd run out of ends. But the end values in your equation would all be the same intensity. That's what your equation said. That's not the reality.
Destructive interference. And you're looking here at an experiment that is historically of great importance.
Alright, so Pirro says he's wrong. This isn't the great importance experiment. Pirro has a different understanding of the history.
It is one of the most mysterious and puzzling issues in all of physics.
So just remember what he just said there. So it's mysterious and puzzling, yet we'll draw conclusions. Is that what you do when you're puzzled and stunned by mystery? Is that you start drawing hard conclusions? I think that's backwards. When you're stunned and confused by a mystery, it's not when you start drawing conclusions.
This interference pattern, which was first shown by Young in 1801, is clearly convincing evidence that light is a wave phenomenon.
Okay, it's convincing evidence. That's that's the argument. And it's, again, so now if we just make this a single slit, and you'll get the same pattern. You won't get this dead spot here. You'll get a more consistent pattern. And yes, the center will be much brighter. But that's the only difference. Is that convincing evidence then? A single slit? I don't think so.
However, 20th century physics has shown that light comes in the form of individual photons.
So what he's saying here is basically Einstein demonstrated that, yeah, there's this quantum, and there's a conservation of energy with these photons, and you can't cut them in pieces. It's all or nothing. You got a photon, you got nothing. You don't have half a photon, you don't have a quarter of a photon. There's none of that crap. It's a photon, fucker.
It's well-defined energies, and photons can behave like bullets. They have momentum, they produce radiation pressure, and they can be localized in space.
Right. All of the things that part of quantum mechanics wants to pretend doesn't exist, but yes, it's clearly what they are. So why are you playing the game? Why aren't you just saying we're interpreting this mystery wrong? So you have something mystery and strange, and you're letting the mystery and strange dictate what you're going to believe. And, you know, like I heard a story about God that created mankind and, you know, put belly buttons on them and all that kind of stuff. I heard a story about that. Well, put nipples on men. Oh, yeah, real smart God. You know, I heard a story about that. I should believe that and just ignore all the evidence that's sitting around me. So I'm just saying we have all this evidence that, you know, photons are really quite discrete, definable, confinable, and they obey conservation laws, which wave isn't compatible with.
We can detect individual photons in a way that we detect individual tomatoes.
Right, by receiving them in the face or wherever you get hit by them. Yes, but you have to receive them. You can't detect them any other way. The tomato has to hit you.
Photons behave like particles. However, the interference pattern that you were staring at on that screen can only be explained if we assume that each photon went through both slits.
Right. So, you know, quite obviously, right, that statement is nonsensical in the context of our knowledge of the existence of single slit creating exactly the same pattern. Approximately the same pattern. So you have a single slit experiment that creates approximately the same exact pattern. I keep wanting to just say exact, but I'll quit saying that. A very similar pattern, almost identical pattern. And we know what slit it went through. In the single slit experiment, we know what slit the photon went through, and somehow it still makes the pattern. So somehow it doesn't evaporate, nothing crashes, it still makes the pattern, even though we know exactly what slit it went through. Right? Right.
But how on earth can one particle go through both slits?
It can't. It won't. It doesn't. And that's the rational context for the mystery. The mystery is now solved by saying, oh, that's just too silly, let's find a real explanation.
It will have to be one slit or the other. And here lies the great mystery.
So now he's going to say that here is now even a bigger mystery, and this won't be based on anything that's called like real evidence. This is just like the stuff, oh, somebody thought of that experiment, and this is the result of the experiment when they thought about it. This is the results they had when they thought about it. But they didn't actually do the experiment.
Light is both. It is a wave if you want it.
Yes, it's a wave if you want it to be. Now that's just brilliant kind of physics, isn't it? Let's just do whatever we want and not pay attention to what it is. So we're trying to describe what something is. So it's like evolution. So if you want the platypuses to be birds, they can be birds. If you want them to be ducks, they can be ducks. Let's just not even pretend it has a genetic code that defines what it really is. Yeah, let's just forget about all that.
To be a wave, and it is a particle if you want it to be a particle. If you manage to determine for every photon through which of the two slits it went.
Okay, so now he's making a claim. So if you could do that, he should have said. But he's assuming you can do it. So he's saying if you do measure photons going through the slit and figure out what slit it went through, all of a sudden now it'll behave differently. Well, you can't measure a photon without interacting with it catastrophically. You have to put something there for the tomato to hit, and then you can throw a new tomato. But the tomato has to stop. Okay, so he's a physicist, and he doesn't really understand that if you're going to detect a photon, it has to be tomatoed. It has to squish against something. And like I said, then you can throw another tomato. But the tomato that it was isn't going to be the tomato that it was. It's going to be a different tomato.
And that is possible to do it at low light intensity.
So he's claiming it is possible low light intensity. No, it's not, because what they use is an electron amplifier to detect photons. So what they're basically doing is saying we detect the photon by catastrophically detecting it. An electron moves a little bit, then readmits the photon, and the little bit of movement in the electron creates movement in all these other electrons that start releasing photons and start, so it amplifies the signal from the one photon. But the one photon has been catastrophically interacted with by the electron, and the electron has emitted a new photon. That's why the pattern is destroyed, is because the photon now has a new trajectory because it's been interfered with.
You can really determine through which of the two slits each photon went, then you will not see any interference anymore. The pattern on the screen will be like that of the tomatoes. You get two piles.
I don't even know if that has been done. So I can't say. I haven't seen that image. Ever. So I haven't seen the two pile image. Because again, you're still stuck with single slit diffraction. So you're still stuck with a problem. You still have a single slit, even if you eliminate the idea of two slits. You still have a single slit, and the single slit is creating diffraction. So how can you have two piles when every aperture of small enough width will diffract or create what looks like an interference pattern? So again, even that doesn't make much sense.
So the moment that you establish the particle character of the light by determining...
Yes, the moment you interact with it in a substantial way, which is the only way you can interact with a photon, is all or nothing. You either catch it or you miss it, but you don't do anything else.
Which slit it went, you have destroyed its wave character.
No, you've destroyed its angular momentum, its directionality, its and you're readmitting it with a new one.
And it will not behave like a wave, it will behave like a particle.
It always behaves like a particle. This is not the behavior of a wave. This is the behavior of little photons being shot in certain angular directions and landing on a target. They're not waving themselves there. They are going there. And they went there right from the slit. They didn't do any interfering way out here. Where did this interference take place? Because if I bring this screen closer and closer and closer and closer and closer, I can't destroy that pattern until I get so close that the slit itself, now the straight lines, will get so bright that they'll wipe this pattern out. So the only way I can get rid of this pattern, if I'm bringing this pattern closer and closer and closer, the only way I can truly wipe it out is I have to bring it so close that the width of the slit, now the straight line photons, bleed over everything and just wipe it out. But there is no evidence of this diffracting thing happening anywhere. Okay, I mean, it would be nice if that phenomenon didn't take place. I mean, if it didn't get wiped out, because then you could see that the pattern is there all the way from the beginning.
However, as long as you do not determine through which slit the photon went, thus as long as it remains your guess through which one it went, like...
Okay, so I'm sitting here looking at the one slit experiment, and I guess which slit it went through. I think it went through the single slit. Yes, I'm guessing that. And as long as I don't know it went through, it'll make a different pattern. No, it'll make exactly the same pattern whether I know it or whether I guess. It just isn't going to fucking matter. Because it's a single slit and it's going to get diffracted, just like that. And that's the truth.
Will reveal to you its wave character, and you will see interference.
So I'm just saying, this canard, this lie has been built into this, ingrained into these people so deeply that even a very good, I mean, this guy knows some shit, man. And even he hasn't thought about what he's saying. And he hasn't combined the two truths, two-slit bullshit and single-slit. And he hasn't recognized that you just can't do this, what slit did it go through, it's a mystery, blah, 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 crap. Because it exists with a single slit, and we know what slit it went through in the single slit experiment. It only has the one fucking choice, damn it. And the pattern is there.
The choice is yours. But you can't...
Now, the choice to say that, boy, this is really a dumb way to do physics, is to pile all of this theory on top of this crappy experiment. That's your choice. Your choice is to say, that's a mistake. That would be the right thing to do, is to say, yes, it's a mistake to draw any hard conclusions based on this crap.
Not have both ways. So you're looking now at something that had a huge impact on physics. Clearly, at the time that this experiment was done, it was accepted that light are waves.
Right. So again, so we're just stuck with this idea that and it's just wrong-headed. If I did that with the single slit, if Young was famous for the single slit experiment, then you'd all be saying something different. But you'd say, gee, light is a lot different than fucking water waves. Excuse the fucking. A lot different than water waves. It does something completely different. So let's figure out why. Because it's obviously not like a wave. It's doing something different than a wave. Alright, so let's, so now I'll do a little bit of drawing. Okay. Explaining. Alright. So I don't even know if you have to believe that photons are not waves, but they're things going through a slit. And the argument is what could possibly be screwing them up, making them go somewhere else. So we know that prisms have surfaces, and the surfaces make the light go in a different direction based on its frequency. And we know that rainbows, little water droplets, the light will bounce inside the droplet, reflect, and then come out of the droplet at certain angles, and that refraction and reflection, two processes, will create an image that you see of separation. And the separation is much like the two slit experiment. It's a it's a similar pattern, and it's being created because the angle, the trajectory of the photon is changed by its interaction with the raindrop. Okay. You could argue further that the photon being emitted by the raindrop probably isn't the photon that went in. But anyway, that's a whole nother argument. Alright, so my point would be is that if you understand the whole idea of atoms and how they're held together, you have electrons and protons. And theoretically, these electrons are this distance is huge compared to their size. So these things are way far away from each other. And so when there's a surface, so this would be like H2O, right? So these could be the two hydrogens, and here's the oxygen, or some arrangement like that. That's a classic kind of thing. And people think of these things as spinning and doing all this kind of stuff. I don't think that's true. I think they're just wobbling in place, and that's being interpreted as spin. They're being pushed in all directions, but they're just staying in a certain location, and that's what makes atoms rigid, because they have places where there's an opening to the plus side. See, this is positively charged, this is negatively charged, and the charge just has to do with, I would argue that this magnetic function or electrical function is a function of polarization, and it's this shadowing thing. So there's strong shadow where the two things are pulled together, and then weak shadowing where they're driven apart because of the natural gravity. So that's in other videos. It's in the paper explaining magnetism. So the point is, though, is that you have repulsive and attractive forces. That can be understood as a general statement inside of atoms. And the truth is that atoms are, they never really show you their proton side. So they don't really have what's called a plus side. They just have a less negative side. And what they have is like a balance. And its surfaces are always just covered with electrons. So you would say that the atoms, the protons will always be deeper inside of the substance. They're not on the surface. The surface is electrons. All matter, I would argue, has that configuration. The electrons are on the outside, and even in a bunch of atoms together, it's always going to be surrounded by electrons. Electrons on the outside, the meat in the middle, or whatever you want to, peanut butter on the middle, chocolate on the outside. And that's the configuration. Now what happens is when there's extra electrons, which can happen because the protons say, I could use some more electron, but it doesn't want to hold one. Can't hold on to it, let's say. But anyway, or something gets charged, or electrons are thrown. So if I throw electrons at this substance, so say it's completely got 5 on each side, let's say, and I throw a couple of extras, there's a choice. On most conductors can just make a choice. Like they'll either both go over here or they'll both go over here. But they won't, one will go over here and one will go over here. No, it'll decide which side's going to be positive and which side's going to be what now will be negative. Well, the negative is obviously the side that has more, so the plus and minus signs are backwards. So it really is. They should fix that, just so I could do this explanation without having to stop to say, look, when I say negative, I actually mean more electrons. So anyway, but there's always a decision, and the difference between a conductor and a non-conductor, like an insulator like glass, isn't the fact that they can have charge. That is, they can have more electrons on one side than they have on the other side, which they'll always have. It just has to do with how fast they can switch which side has charge, how fast the charge can be moved from one side to the other side. And so when two surfaces come in contact with each other, what automatically happens is one becomes positive and one becomes negative. They're never, if they're both of them have because I previously charged them, so both of them have more electrons on this side, they don't like that configuration. Electrons hate electrons. Okay, they hate each other. As much as I hate that Makulgage, they hate each other. And so what will happen is, if these are conductors, if one of these is a conductor, the conductor will just switch all the electrons to the other side. And so this now will be the side with more electrons, that is negative, and this will be positive to meet that negative, to balance it. And that's what charges will do. It's their nature that that electrons don't like each other. If one of the substances can move a bunch of electrons to somewhere quickly, it'll do it. And so they all run to one, they're all pushed to one place is the point. Even though the electrons don't like each other, the other electrons don't like them more, is sort of the argument. And so they always have to be pushed away, and they'll always be pushed to one side or the other side. It'll become a charge, a plus side and a minus side. It just won't acquire them on both sides. how's a good way to explain why that is because once the imbalance is established, it's like a flow in a river. It decides which way the river's flowing, and so it'll always have to go downstream. You can't push it upstream anymore. It'll always be pushed downstream. So it just decides kind of the flow of the river of the material. And like I said, with a conductor, you can change the flow of the river easily. And with an insulator, it doesn't really want to change. So you have to almost drag, you almost have to pick up. Like you could have a piece of glass with 1,000 volts of charge on it, but you can't get it to come off. So you almost have to like pick up all the extra electrons and push them over to the other side to get them over there. You have to like pick them up and put them back on the other side. They just won't leave. Probably not the right way to say it, but the charge is difficult to extract because it's stuck in the protons. So anyway, point is the surfaces have electrons surrounding them, okay, and they're always going to have, depending on the atmosphere. See, the atmosphere will break down a voltage. So if one side has a lot of electrons and the other side has very few, then the atmosphere will allow them to be transferred to the other side. And that's what we see as a spark or a glow. Okay, and it's called a breakdown voltage because the atmosphere is a conductor at a certain voltage. At certain voltages, it's a conductor. Lower than that voltage, it's not a very good conductor. But anyway, the point is that the number of these electrons isn't going to change unless they can all be switched over to some other side and blah 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 and change the charge. But the charge is going to be neutral in the two substances because they're likely connected to ground somewhere and blah 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 blah. So I don't really want to get into a whole complex discussion of that. I guess what I want to say is, if you think of the field around all matter as being, surfaces aren't like this pen is not pen, you know, on the atomic level. On the atomic level, the surface is complex. A bunch of electrons in different relationships to their protons that are holding them all together. It's a matrix, and the exterior wall of it is electrons, not pen. Okay, it's just not, it's not made of pen. It's made of atoms. And atoms have parts, and the parts are what are, the surface is made out of parts, and the surface is made out of electrons. Electrons is what makes it possible for there to be a repulsion between things, that they don't go right into each other. It's electrons that are creating the force field, so to speak, between substances, the surface. And it's this surface that refracts light, because there's a bunch of electrons on it. So when the water reflects the light, it's because there's electrons on the surface of the water. If glass reflects light, it's because there's electrons on the surface of the glass. And they can either make the light go that way, or they can make it go that way. And they'll do it at specific angles based on their spin and based on the chemistry of the substance you're interacting with, because that'll dictate the position of the electron. So anyway, just to understand the two-slit experiment, understand, okay, so there's a certain number of electrons associated with this matter when you have these two slits. And they're set. It's a set number. And you can't get rid of them because they're part of the chemical bond. They're part of the field that's going to exist around anything that has that chemistry. And so what happens is as you get these two, so this is a field essentially around the substance of these electrons. Now, as you push these two things together, these electrons can't go anywhere, but they don't like each other. And so you start pushing them into a denser field, a tighter space. So now they're thicker. There's more of them. So you make the space smaller and smaller and smaller, there's more of them. So now just think of your little photon coming in and say, when the field is open, clearly light can go straight, it doesn't get bothered at all. And let's just say every time it hits an electron, it gets changed by an angle of 4 degrees, let's say. So there's a 4-degree angle. It can go 4 degrees this way, or it can go 4 degrees that way. It can go 4 degrees anyway, but it goes 4 degrees. And every time it hits an electron, it'll go 4 degrees. So it could hit an electron, go 4 degrees, then hits another electron, goes another 4 degrees, hits another electron, goes another 4 degrees. So now you're adding up 16 degrees, right? So now that photon's 16 degrees off of its normal trajectory. And likewise, you could go 4 degrees and then back 4 degrees this way and then 4 degrees that way. But it's still, even if it does 2 4-degree shifts, that's likely to give it a different trajectory, because now it went some distance at the wrong at that 4 degrees, and that obviously is going to change. It's not going to be a parallel line. But regardless, the point is it would always be at the same increment, 4 degrees. So you can just keep adding 4 degrees plus 4 degrees plus 4 degrees, and that's what gives you your bars. Is it, if it only gets diffracted 4 degrees, well then it ends up near the middle. If it goes 8 degrees, it goes up over here, 16, 32, blah, blah, blah. Go down the list. Not 32, but just add 4 to each one. Not multiples of 4, just plus 4. And so you could understand that the denser, the tighter I make these slits, the more likely a photon is going to hit more than one electron. You know, right? It's more likely it's going to hit more than one electron. And now it's more likely it's going to be 8 degrees or 16 degrees or 32 or 64 or some other big number of shift. Because now there's a chance it's going to hit more electrons, because I pushed more of them into the center. Because they can't go anywhere. They can't go out here. They can't go over here. They have to stay here. And they just get thicker and thicker and thicker. So as I make the slits smaller, I make the odds of high degree refraction higher and higher. As I make the slit wider, it means there's more and more likelihood that the photon can just go straight through. You get it? So that explains why the narrowing creates more diffraction, because you're creating a higher incident of refraction with an electron. The photon interacts with an electron, gets absorbed for an orbit, and is expelled either a little too early or a little too late. And that explains the pattern. On, off, on, off. 4 degrees, 8 degrees, 12 degrees, 16 degrees, 22 degrees, no, 24 degrees. That's it. That's the explanation. Or an explanation. A viable theory. A postulate of possible, reasonable explanation. But it's just the density of the electrons is increased as you push the surfaces together. And we can sort of see it. Like, you just put your fingers together, you'll see the lines. You'll see the compression of the field. So is there anything I need to add to that? I mean, there's obviously a lot you could add to it, but the point is that again, it's understanding, Piero just doesn't understand frequency at all. I mean, he just thinks everything with a frequency has to be a wave. And most things that have a frequency, even a sound in your car, yes, when you're receiving it as sound, it's a wave. But what made it wasn't a wave. It was something hitting. It was doing this. It wasn't waving. It was banging. It was knocking. It was a thing coming at a frequency. It was a machine gun shooting bullets at a regular interval. It's not a wave. You could call it a wave of bullets. People have done that. But they're individual bullets spaced by a certain distance, created by the timing cycle of the rotor that's injecting the bullets for ejection. So photons, I've done this before, but the intensity of photons, everything about photons it just isn't spectacularly difficult. Okay, this is a red light. This is blue light. That's the difference. Okay, in the same period of time, The reason why blue light is more intense is because there's more actual tons, because they're closer together, their period is closer. So this would be your, whatever, 500, 600 nanometer wavelength, and this would be your 300 nanometer wavelength. And it's really just about the period. And so the amount of time, and the more time it takes between incidences, the less intensity, the less fewer ball. If these were bowling balls and somebody was rolling them at you, you could certainly tell the difference between getting hit by 4 bowling balls and getting hit by 8 bowling balls. So I mean, obviously blue light seems more energetic because it has more bowling balls in it. I mean it's just so perfectly conservational. It makes it all quantizable. It makes it all add up. Now it makes it understandable how you can, have a little bit of blue light create a lot of red light. It's because there's a lot of little bowling balls. I have 8 bowling balls worth of blue light. I can now create twice as much in terms of time of rolling. I can roll bowling balls twice as long if I roll them in the red manner. See, so it appears like it's more. What is more? There's more bowling balls. And all I'm doing is changing how much time is in between when I throw them. And that matters to the electrons. Electrons care about how quickly the thing comes into them. So you can kind of understand. Trying to use different examples, but it's like a wheel spinning, like a baseball throwing machine. The wheels spin, the ball hits it, and it rolls out. And if I put a white line on there, you could kind of see that the wheel spins a certain number of times before each ball comes in, and there's a certain pattern created to that rotation. And electrons are sensitive to that pattern. They can only capture something if they take 1/2 turn before another ball shows up. So as long as another ball shows on a 1/2 turn, they'll grab it. But if it shows up too early, before like here, or while it's here, then it goes right straight through. It can only grab it when it hits on the right period of the spin. So that's why some electrons will grab, depending on their orbit, some will grab blue light and some will grab red light, depending on the substance. That's why some substances emit a different pattern. Interferometry, whatever you want to call that, where you burn the stuff and you see what kind of colors are emitted, indicating what the elemental substance is. It's because those electrons are at certain states where the spin speed is at a speed where it's going to be able to it'll emit red light because it's spinning at that speed, or blue because it's at that speed, but it's going to be at a different spin speed. Alright, well now we're getting into a completely different subject. I just want to stick to the 2-slit thing. And so you heard it from the guy's mouth. He basically said this is our foundation for our wave theory. Here again is his drawing of this is where he's talking about kilowatts. It's written right here in watts. This is what he's saying. This is a definition of intensity. Again, I don't have to show it to you again, do I? There was no consistent intensity to those light sources, those light projections. All right, I think I've covered it. I mean, it'd be nice if the final wave picture was still here. Well, there it is. The circular wave with the same wavelength as the waves coming in. So Marcule guy, he's a physics professor. Why didn't he draw diffraction here if he thought single slits create diffraction when un-overmodulated waves are a source? Because they don't. So where's your ton of evidence? You don't have it. And instead of being a decent person, you're just lying about me, the credibility of my arguments, the integrity of my arguments, And it just makes you a despicable piece of shit. You're a liar. Yeah. Despicable liar. But so are most people, unfortunately. Alright, so I think I've done my job here. Yeah, I don't want to. Why make it more complicated? I'll do the. I mean, I've done the gravitational lensing thing. I don't know if I want to do that again. I do want to just get to this electron thing, because this is really sort of important. So I am going to try to do some more videos on electrons and charge. Because that whole dynamic is what. That's all there is. The moving electron is the thing producing. The guy even said, he read it out of the other guy's book, only moving charges produce fields. And by moving charges, he means moving electrons. And they can't be just moving this way. They have to actually go somewhere. If they do this, then they basically give what they take. In a sense, you know what I'm saying? They don't produce anything, because whatever they produce going this way, they produce exactly the opposite thing. So if they create B energy going this way, they create the A energy going this way. You know what I mean? The opposite. Plus, minus. So yeah, if they go this way, they create plus, and then they play exactly the same amount of minus, so they neutralize each other. So a charge vibrating won't do it. A charge has to move its location to do it. Well, he said accelerating charges, and I don't think they have to accelerate. They just have to move location. But to move location, you have to accelerate, obviously. You have to start, and then you have to stop. Yeah. Anyway. So, till next time, and such. And so forth and whatnot.